Thanks for joining me and JP. We're super excited to be here. It's quite early for us. It's 4 a.m. for JP and 1 a.m. for me. So we're totally committed to this one. So thank you for joining us again. We're going to be talking about service principles and managed identity, and we'll show you how to build secure DevOps, secure apps, secretless apps, eliminating all the the security threats that you might be getting with some of the technical capabilities of the managed identity, the Microsoft Active Directory and Microsoft Identity Platform. So let's get started. Me and JP, we're here. We are developer advocates for the Microsoft Identity team. We have a show. We stream every Monday and Friday. So if you like what you see today, if you're interested to the things that we talk about, then make sure to join us on the 4 to 5 show. It is a show about identity that is not just about identity. We build everything and anything that has to do with code and authentication and security and DevOps. So this is the short introduction we had, and for the first part, I will introduce my demos and talk about our platform, and then JP will take it from there. So why we're here today? We're here because we love everyone. We love developers, we love IT pros, and we want to make sure that when you're building apps, when you're running your apps in the cloud, especially on Azure, we give you the right tools to do this securely, eliminating any risks for you, yourself, and your customers. And with that, I'm going to let JP say what and how.
Sure, thanks. Yeah, good morning, Christos. Good afternoon, good evening. In our platform, we don't really care what kind of platform you're using. We don't really care what kind of cloud you're using, what sort of coding platform you're using. We want you to be secure. We want you to have confidence in your identity system that when you have users and you've added users in, and that you need to sign people in, that you don't have to be an identity pro. You don't have to be really deep on identity and protocols and a wizard in order to have confidence that you're going to sign a user in and not end up on the front page of the news because somebody stole your database. And so where we sit is in somewhat of a unique place, especially compared to kind of the rest of Microsoft, is that our identity system can be used really with anything, with apps that are hosted nearly anywhere. So as long as your apps have an outbound HTTPS connection that they can make out to our identity endpoints, it can run wherever. It can run on-prem. It could run on a Raspberry Pi. It could run in AWS or in Google Cloud or in Oracle's cloud even. It can run anywhere. And we work with lots of different vendors to make sure that we have clear instructions and that we have sort of proper integrations with different tools. So the JetBrains toolkits, things like PyCharm and Rider, IntelliJ. Of course, we've worked with those teams on getting those kinds of integrations in to make integrating with Azure very easy, or to make integrating with Azure Identity very easy. But of course, if you're working in our platform, if you're using .NET, if you're using Azure, if you're using Office, of course, we have sort of first-class integration there too. So that helps keep us. That gets you to a point where a lot of the integration there is really tight, ready to go, and you don't have to be a pro to get it going. You don't have to have any super specialized knowledge in identity. Of course, what we see a lot with our customers and with the developers that we work with is identity is important, but it's also sort of overwhelming. It's very esoteric language, lots of very specific protocol stuff that you have to understand in order to feel like you're implementing it correctly. But it's item number 7 on a punch down list of 900 things that need to happen, right, in order to get an app out the door. And so we try to understand that. We try to reflect that in our libraries, and that our libraries sort of help get you to a good state very quickly without having to be really, really deep in what all those different things mean. So what we're going to show you today, we're going to talk a lot about sort of both sides of the life cycle, from how do I build an app locally that connects to perhaps Azure resources or connects to other APIs that are secured by Azure AD. And then we're going to take that up into deployment of, well, this is cool. I've got my apps. I'm pushing them somewhere. How do I go make sure they get deployed? Get deployed in a way that doesn't require me to have secrets, right? So one of the most common things that we see is I've got a secret for a client secret that I need for my authentication to work, or that I need to call another API, and then inadvertently it gets checked in and it gets pushed into some sort of some repository like a GitHub, or into like a Bitbucket or wherever, and now suddenly these secrets have been compromised, and they're sitting around on the and they're sitting out there on the internet for people to use to access your resources. In fact, there's a website, which I don't remember the URL to, but there's a website that shows those in real time as they're being checked into GitHub. So it's one of the largest places that we see a lot of problems. And so what we're going to show you today is a lot of different ways for both building those apps in a way that doesn't require you to have secrets in the first place. And then when you are ready to deploy them, deploying them to Azure without having to have credentials that are stored in a file somewhere, or credentials that are stored somewhere insecurely, just to get your app deployed.
That is correct. That is correct. And we've worked with a lot of customers. I've been to a lot of customer sites as an engineer for Microsoft, and we've seen this time and time again. In fact, I've done it myself as a developer. You create your .NET app, your Node app, and you need to stick some configuration settings somewhere, and you end up checking these secrets somewhere in your code, and that code eventually makes it into some production. Now, it might not always make it into an insecure place, but there are other things that you need to consider. The threat model analysis, that if you give developers access to your production system, things will inadvertently happen. I've seen people deleting databases and resources from production systems because they had access to sensitive information. I've seen people maliciously. I mean, that was accidental, but I've seen people maliciously. There was a big story from San Francisco a few years ago where one of their IT admins was fired. He was disgruntled, obviously, because of that. He didn't agree with the whole thing. He was let go back to his desk. So he encrypted I think it was the public transport main database. So for about 3 weeks, they were forced to let everyone travel with public transport for free because the system could not run. That guy was taken to jail. He was also fined, but he never disclosed the secret. So they had to find backups and they had to restore from backups. It was a very painful process. You don't want as a company to have that liability, and you don't want as a developer as well to end up down that path. Like, don't have that responsibility. So from our perspective, when it comes to working with code, the last thing that you want to do is having to worry about secrets and managing those secrets. And and as a company, you don't want to make them available to everyone. Now, today we're going to be talking about service principals and managed identity. That was the title of our session. So I want to take a little bit of time to explain what these are in the context of what we're doing, and then we will show you in action how they benefit you when you develop code. So let's start with the service principal. Service principal account is more or less a service account for the cloud. Back in the old days, when you had your own on-prem environment, you would create service accounts that could run daemon tasks or automation tasks. And that was great, and it was all managed internally in your network. Now in the cloud era, you don't really have that one. You don't have that kind of network. So you need some kind of a service account that gives you permissions and scopes to do certain things. So for Azure, when you work with Azure, service principal in effect is it's a special account that allows you to run certain things. That can be a web app that they can go and speak to a service. It could be a specific account that you run an automation task in Azure Functions, and it can go and do certain things. When you develop locally, you can also use service principal accounts to connect to your production environment or your any environment under certain scopes. The nice thing about service principals is that once you define them, your IT team can define them. They will pass that information to you, and that allows you to run certain tasks without you having to worry and manage those accounts. However, service principals do come with secrets, and that always creates a little bit of a problem. But if you are running, say, .NET Core app, and we'll use .NET today. In fact, .NET 5 was announced yesterday, so happy .NET 5, everyone. I hope you got a chance to download and play with that. The first demo that we're going to use is an ASP.NET 5 app running locally in my machine that connects to Key Vault. Key Vault is a service on Azure that allows you to store secrets, it allows you to store certificates, and other keys. And the idea there is that somebody centrally manages the secrets for our app. And our application is going to consume this, whether it's local or in the production environment, without me having to change any code and without me having to pass any secrets to connect to that service. So a very basic example, let's switch to my app here. A very basic example would be, I have my .NET app, and I have an app settings file where I need to store some secrets. Imagine if we had something like a SQL Server connection string, right? And I had to store that. Now, we don't want to store that insecurely. And hopefully you're using a strong password or a strong connection to your SQL Server. Please don't use SA with no password, just for the ease of it. So the idea there is that inside our config file, we have a few settings, and we want to pull them out at runtime. So as the application starts up, I want to populate my some config value from Key Vault or KV here from Key Vault without me having to do anything. And to do that, there's a nice provider for ASP.NET that when we go into our in our program page, I will show you here. So as our application is getting bootstrapped, let me close this one so we have more real estate. Our main program enters, and then here we create a host builder. The first thing that we do is we try to connect to our Azure Key Vault to populate that sensitive information inside our config file. Now, as you can see here, I'm pointing to my production Key Vault, but I have no secrets whatsoever. You'll notice that there's this kind of chain token credential. That's an Azure SDK capability and Azure library that we have that allows you to create tokens or acquire tokens for services without really authenticating. It will use my local account. In fact, it uses the local account I have signed into my VS Code. So if I click on this one, you see I'm signing with my my domain account. And then this one, the Azure CLI credential, that's the one I'm signed in as well in my Azure CLI. I will use that account to authenticate. Now, this happens on my local machine, and we'll see it in a second as the application runs. But when I take this application to production, we'll be using a different account called the Managed Identity, and we will explain what a Managed Identity account is once we move to the cloud. So let's run the application, and let's see it in action. So I'll come here. In fact, it's already running. Let's go to our app. So if I go to my home page, you notice that the config secret, so we're pulling that secret here with big letters so everybody can see it. This is a config value that this one is coming directly from Key Vault. And then if I switch to my Key Vault secrets page, we're pulling some extra information. So this is the Key Vault secret again. This is the one that we pull from Key Vault at start time. And then we have a real-time one. Let's see how we do the real-time pull. So there might be a case where I need to pull some information at runtime, not at startup. And this one can change dynamically. So I will go into Key Vault and change this. So you notice here that, again, we're using the same pattern. I'm creating a Key Vault client. I am authenticating using my local credentials here. And then in the cloud, I'll use the Managed Identity. And then I pull my KV secret. So if I switch to my Key Vault now, let's go to our Azure Key Vault. You'll see that we have this one, this value here. So let's change the version. Let's put a new secret here. We'll say, hello, build conference. Did I screw this or not? Let's find out. A lot of letters to type without making a mistake. So if I come back here and I refresh that one, there you go. No typos at 1 o'clock in the morning. That's brilliant. So how did this run? Well, we have my local account running here, and everything is being pulled directly from Azure Key Vault. I don't have any secrets in my app. It's a secretless app. You can also do this in Node. You can also do this in Python. We have the same exact libraries that you can use in your code. So obviously, it might not be the same as the Azure, the .NET provider for pulling configuration files, but you can use the same library exactly to pull the secrets along as you need them and consume them in your application. Now, I'm going to do a small change. Let's stop the application from running. And what I'm going to do here is I'm going to stop the application from running locally, and then I'll go back and change, let's say, something into the index, the config secret. Let's make this big letters and uppercase. Let's save this one. And then let's go and commit this code, because I want to show you how this will run in production. So I'm pushing this into GitHub, right? This is where I store my source code. I'm super happy about that because I don't have anything secret. I don't have to worry about stuff being pushed into GitHub. I don't have to change anything. I don't have to hide anything. I don't have to go into my Git ignore and ignore files that might contain sensitive information. And let's switch to my GitHub repo now. This is where we have everything. In fact, let's refresh this one. We'll see build configure. There you go. That's build stuff. Just committed. So what do we have here? We have a workflow that will take my code and deploy that into Azure. It will deploy the resources, the website, and a SQL database at the back end, and then it's going to deploy that code. So we have the infrastructure bit and the production bit. So let's check the workflow here. Now, because I'm creating a SQL database, I need to provide a SQL admin and a SQL password so that the things can work. So let's look a little bit at the file here. If you've done GitHub Actions, in effect, it's a CICD pipeline that allows you to take your code from a specific repo and deploy that to an environment. In this instance, we're deploying to Azure. So we have my Azure web app name. We're using .NET 5, so you can run .NET 5 today on Azure web apps or Azure Functions if you want to. So the first thing we're doing here is actually logging in to Azure. So my pipeline knows how and where to deploy things. And you'll notice that there's this thing that makes me a little bit cringe because I have to provide some credentials. If you want to see what these credentials look like, these are the credentials for my Key Vault, for my Service Principal. And you might say, well, Chris, how do you create a Service Principal account? So let me clear this out. I did not want to do that. So let's make this big so everybody can see it. So if you're, is it clear? Oh, there you go. Okay. So if you ever want to create a Service Principal account, the command is AZADSP. So Azure Active Directory Service Principal create for RBAC. This is a special command that says I'm going to be using this account for deploying to Azure. You don't have to create for RBAC, so you can have a standard account. And then SDK auth, it allows you to pump out some information about your pipeline. For the Service Principal. It's different to the standard command because it will create more information about what the information you need to sign in. So you'll see the endpoints that it needs to go and call information for. Also, there's a client secret here. So this is something that we want to eliminate. I need to copy the whole thing here if I were to do it now. And then in my pipeline, I need to go into my secrets in my settings, which is here, and I need to provide that secret so my CICD pipeline, my GitHub action knows how to log in. So you'll notice we have Azure credentials. This is if I were to update that, I would copy paste that whole thing in there. Right. So let's go back into my deployment pipeline. Let's see. So we have the login. That's the important bit, and it will do it automatically. And unfortunately, this is not the greatest, and you'll see how we can do it even better in a few minutes with JP on standby over there, eagerly trying to show you or waiting to show you. So the first thing I'm doing is deploying an ARM template. That ARM template is actually describing my infrastructure. There's a JSON file that says you're deploying a web app and a SQL server, and there are some parameters here. This is where I need to actually disclose that information. So this is a little bit tricky because how am I going to put my SQL server credentials there without really compromising security, right? And we've seen so many people do that in the past where they would take the parameters file, stick it into source code, and use that for deployment. So if we go back into my deployments, looking at my ARM templates, this is the parameters file. You notice I have the old way of doing things down here. You'll notice, very common. I've seen many people do that. And this is awful, by the way, putting your secrets here. We don't want that to happen. So there's a better way. Is there a better way? There is a better way. We're using a Key Vault version now. So you'll notice that what I'm doing here is instead of hard coding my login password inside my ARM template, I am doing it by referencing my Key Vault. So this is my Key Vault name all the way down here to in my subscription, and then I'm passing my login password. So if I jump very, very quickly to my Key Vault, you will see there. There you go. You have a SQL login and SQL administrator. So this is this is where the information is coming from. So going back to here, we don't have any secrets whatsoever now. And if I go into my actions, let's see if that has run already. It's running now. So it should take a couple of minutes to deploy, but since oh, there you go, it's started deploying. So it's setting up my .NET Core project, it's building the project, and we'll run the web app in a few seconds. We're gonna jump onto the actual live environment. So the nice thing here is that once it logged in, you'll notice that if I open here, it uses my credentials that I passed. It outputs some information, some logging. It says that it successfully connected. So we're all good, success. It's fantastic. So we're all logged in using that service principal. I did not have to use my own account. And that's important because your own account has very, in most cases, you either have too many permissions to do things across multiple subscriptions, like me and JP usually have. We're full admins and owners of multiple subscriptions, so we can wipe out stuff. Or in some cases, as a developer, you might not have enough access to do things in the production environment, and you need to use a service principal account. So I think that's the deployment done and completed. So if I go back into our Azure subscription, I can jump onto my website and browse to it. Remember the URL. So there you go. If we browse to this one now, that's the exact same code that was running on my local environment. It's warming up a little bit, so it might take a while. There you go. Exact same thing. And if I can jump to my keyboard secret, that's live. But as I said, this is great, but it made me cringe a little bit because I could not eliminate all the secrets. I had to put that secret into my GitHub repo. So I wonder if there's a better way of doing things, JP. What say you?
So there is a better way. It is pretty cool. Don't get me wrong. The idea of not having to store your credentials or store some kind of credential in a file somewhere at least. Mm-hmm. But it kind of got us thinking of, well, what's an alternative? What's another way that we can start to do this, right?
Yep.
And so one of the things we offer in Azure is something called a managed identity. And you generated an identity, right? So you've got this identity, this blob of JSON that you created from the shell, from the cloud shell. You've got this blob of JSON, and that blob of JSON is sitting there. And one of the fields in there is a secret. And so that's a secret now that you're going to own. And so at some point, that secret's going to expire. And usually it's within about a year. So by default, those are going to be a year. You have the option to have non-expiring secrets, but that's an awful idea. And we would, of course, advise you never, ever, ever to have an unexpiring secret. So for all intents and purposes, the secrets expire after a year. And the problem is that you created that right now, which is currently, March 249th, and it's 4:26 a.m. And so next year, if we ever make it to next year, on the following March 249th, you're going to have to remember, I need to go and clear out that secret. I need to go reset that secret, because otherwise your deployment pipeline is going to stop working. Because now your secret's going to expire, which is essentially a password, right? Uh-huh. So we end up in a place where service principals are really cool. They give us a really tightly scoped service account that we can use to connect to Azure resources and Office resources and even our own services if we want. But we have to figure out what to do with figuring out the life cycle of them. You can also use a certificate instead of a string secret, instead of just like a random bit of text. But at the same time, it's still something that you have to manage. Now, with our larger customers, we tend to see certificates being a little bit easier to manage because larger customers tend to have their own sort of certificate authorities where they can rotate those on their own. But those are for very large customers too. Not everybody has a certificate authority. Not everybody has huge rigor around making sure that we create the right handle life cycle of certificates and things like that on the same way. And so for me, for someone like I've written code for a long time, and so my goal in life is to write code and get up and go do other things, right? So I want to get done with what I'm building, and then we start talking about deployment and everything, and it's like, this is too much. I don't want to do this. So instead, I don't really want to remember to manage a secret because I won't remember. And inevitably, my deployment pipelines will fail, which is why half of my deployment pipelines fail, because I have string secrets in there that have expired. So instead, it'd be really cool if we could do that without me having to manage it, right? And so in Azure, we have this thing called a managed service identity. And a managed service identity, in effect, is the same thing that Christos created. So it's a service principal. So it's a principal inside of Azure AD that can be granted access to do things like read a subscription or create resources or deploy code. The difference is that you don't know the secret and that you don't control the secret, but instead you access the secret through some well-known means. Specifically, running in Azure, we can create these managed identities. So we're gonna go look at a virtual machine. And so this is just a normal Azure virtual machine. There's nothing crazy or special about it. It's a virtual machine that's living in a virtual network all alone, so it doesn't have any other servers that are out there. And it has SSH and RDP from my office. It's not just sort of wide open sitting out there on the internet. So this virtual machine, you'll notice there's something called identity over here on the side. And by enabling an identity, we've essentially given our VM itself an identity. So we've given our VM a way to log in to Azure or other things and then do stuff based on what kind of permissions it has. So this virtual machine is called a GitHub Action Runner, which is probably a little bit of an indicator of where we're going with this. But so this virtual machine is a GitHub Action Runner. And so GitHub Actions can be run by GitHub themselves, or you can run them on your own hardware. So if you've got really specific requirements around really specific requirements for dependencies for building your app, or for an environment where you need to build and deploy your app, or other kinds of tasks that you need to do that the GitHub Cloud runners don't support. Instead, you can deploy your own machine, be it on-prem or wherever, and then use that as a hosted runner. So for us, our runner being an Azure virtual machine, since it's a virtual machine and we can assign this identity to it, and you'll notice we just have a GUID for the object ID, now we can use this VM to access other things inside of Azure. In particular, we can give this virtual machine rights to publish apps or run workflows that will ultimately publish apps with Azure CLI or PowerShell into Azure. So if we look at Azure role assignments over here on the side, you'll notice that this virtual machine specifically has two rights. So it's a contributor to both my subscription and a whole collection of subscriptions that I own. So it makes this VM fairly privileged, but of course these can be as tight and granular as they need to be depending on whatever it is that you're doing. So for me, I want it to both create resource groups and deploy resources into it, and so that's why my permissions on this one are somewhat high. But at the same time, these can be scoped to whatever specifics you need in order to sort of get your code deployed. So typically what we might see is a resource group only. So just a single resource group that owns all the Azure bits that you need to deploy, like your SQL database or your web app or the various pieces. That may be the only thing that you have access to here. In fact, if I was to add a role assignment, you'll notice one of the things we can add access to is just explicitly a key vault, or just explicitly a specific resource group, right? Mm-hmm. And so the managed identity itself, we can add it to assign rights to it, let it do things that we would normally be able to do with, say, a user account or a service principal. The difference, however, is that you'll notice that we have the ID of the objects. We have the identities ID, but we don't have any sort of a secret anywhere on here, right? So we don't ever actually see the secret. And the secret itself is rolled and managed by us. So us being Microsoft. So we handle rotating that secret. We handle keeping that secret safe. And these secrets are all certificate-backed secrets anyway. And whenever you need a secret, or whenever you need a token, I should say, you come and ask a specific endpoint, right? So let's get back to GitHub for a moment. So in GitHub, we have this action. And this action is going to do the same thing that Christos did. In fact, this is just a fork of his repository. And it's not the right one anyway, because I have the wrong one up. I need to get back to mine. Sorry. Forgot from yesterday when we did this. So, I don't know. Do you still call it yesterday? Because it was like 6 hours ago. So everything's a little fuzzy. A little
Well, it
fuzzy
was
this morning.
different date, so I think it was yesterday. It was the 10th, right?
That's right. Different date. We'll go with that. So this is a fork of Christos's of his Key Vault web app that we just went and took a look at. And there are going to be a couple differences in my workflow, but nothing too crazy. The first one is I have a different web app that I'm deploying to because I'm deploying into my own subscription instead of into his. But one of the big changes you'll see is that it runs on self-hosted. So that means that this workflow is going to execute on my self-hosted runner. So it's going to execute on my VM, and of course, my VM is running in Azure. The second thing that's different is you'll notice that it's using, at least currently, it's using my branch of the Azure login, the Azure CLI login. We're working on getting that PR through so that this can be available for everybody using the standard Azure login. But this Azure login activity, you'll notice there's a new flag here for enable managed identity true, right? And so by doing this, because the rest of this is standard, so the rest of this is pretty much the same thing. We're going to go deploy an ARM template, set up .NET Core, build and publish the app, and then be done. So the difference, however, is you'll notice there are no secrets in here at all. No secrets. There's no sort of secret tag anywhere inside of this workflow file. And if we go into settings for my repository, for my fork, and we go look at secrets, you'll notice there are no secrets in here at all. So I didn't create any service principals in order to do this work, right? Now, one thing, of course, that we did do was that in Actions, you'll notice down here at the bottom, here is our MSI Action runner, right? So here's our machine that is gonna the remote machine that's gonna handle our build. So let's go look at the actions and look at one of the history of one of these. So this was a build that we did 11 hours ago, and this is running on build and push. Or on push and PR. So we've got our build and deploy web app in SQL. And if we take a look at what's happening in here, this is going to look really similar to Christos's too. So we set up our job, we run our checkout, but now our login via CLI is going to be a little bit different. So we're going to run it. There's some, of course, setinv has now been deprecated at GitHub, which we need to go fix, but there's a lot of goop here, a lot of blah, blah, blah. But then you'll see preparing to log in, managed identity is true, and it's attempting a login. And the login is just login -- identity.
Nice.
One of the things that's neat about Azure, the Azure CLI, is you can use this on a VM. So if you're on a VM, you do an AZ login -- identity, it will use the managed identity that's on the VM. You don't have to do anything extra, short of just running the command on your VM to get logged in. In some ways, this action was super easy to build because it's really just sort of hijacking the commands before they go out and simplifying them greatly because all the logic to connect to managed identity is in the CLI and in PowerShell.
So
and then,
you
of
don't
course,
have so you don't have the same secrets as I had in my settings, right?
That's right. There are no secrets in settings. In fact, I have no settings, right? There are no secrets listed at all. We don't have anything in there because in reality, I don't have any sensitive information that we need to store. And so there's a bunch of other output and a bunch of other goop, but at the end of the day, we see Azure PowerShell session has successfully initialized and the login was successful. So now we have this authenticated context inside of our GitHub action, and then we can use that action to go both do the deployment of the resources, the SQL database, the web app, etc., and then also push the code to it. So we deploy our template, we go and do our .NET build and publish, and then we get our application running, and there we go. So this is where the deployment happened. This, of course, is all requires an authenticated context to Azure, and of course, these both go and run and work pretty well. So in order to get that set up, it's kind of a two-step process. Create a VM, make sure that identity is enabled, and of course we can enable identity, a managed identity for a VM through lots of different ways. You can do it in an ARM template, you can do it from CLI or PowerShell, and of course you can do it from the portal. Once that's set up and created, then it's just a matter of installing the GitHub runner itself, which it's probably It's probably almost too much to say it's an installation, because it's download a zip, extract a zip into folder, run binary, right? When you run the binary, it links it up. There's a special key you use. It links it up to GitHub Actions, and then now it's available. So the way that this shows up in here, in your GitHub Actions, under Actions, adding one of these is kind of a two-command sort of a thing. If we were to add a runner right now, and which is of course is available for all the different platforms, you'll notice we are downloading a zip, we are extracting said zip, and then we have a specific token that links these together. That's all it is, right? Which now becomes, and this is how we use it, which is then of course just use this, runs on self-hosted. So now I've got a GitHub runner, and anything I need, if I need a specific version of the CLI on there, we could have a very specific version of the CLI. But for our case, we were really mostly interested in doing deployments without having to worry about storing any secrets anywhere. So we don't have any secrets in my repository at all, and we can get our app deployed and out into Azure, which is
But
great.
we can do better though, right?
Yeah.
Yes.
So
even better.
So managed identity is super cool. One of the most common things that we hear, and one of the only disadvantages, is that managed identity is only available within Azure, right? So you can use managed identity with a virtual machine scale sets, Azure App Service, which is sort of our web app, web hosting paths, right? Azure container instances, which is kind of cool if you think about it. So you can have a container that has an identity for talking to other services, which is really cool for deployment type tasks, right? Because we crank up a container, it goes and does.
Yep.
It goes and does some work, and then after it does the work, the container is gone. But you don't have to worry about how do I push these credentials into this container, that sort of thing. So there's one extra thing that we can look at instead for doing it locally, right? So local managed identity for a long time has always been sort of a pain point for folks. But instead now we have something called Azure ARC. And Azure ARC is a service for managing machines, regardless of where they are, kind of like they were Azure machines, right? Kind of like an Azure VM. And you'll notice there are lots of different sort of mechanisms for using ARC for different types of things. So for things like if you've got an AKS or even an EKS cluster somewhere else, if you've got a Kubernetes cluster that you've deployed yourself on-prem or wherever, you can put those under management with Azure. But we're most interested in servers. And so you'll notice there's a server here called JPDA X8930. That happens to also be the name of my machine here that I'm doing this presentation from, which is my workstation here at home. So because this machine has been onboarded into ARC, a couple things happen. We can do policy and security stuff, but that's all a bunch of stuff that your IT admins and operators will be really, really excited about, that they can manage machines remotely with things like Windows Update Policy, whatever. But the thing that's really cool from a developer's perspective is that now you get a managed identity endpoint on your local machine. And so now you can your machine now has so now your machine has an identity that it can use to go and do other things, right? So let's go look at Christos's code. I forked his code earlier and made one change. So instead of using the managed identity credential that he had and the Azure CLI credential, which is going to run as me, instead, there's this new one here called hybrid managed identity credential, which is a chunk of code that I wrote for talking to this local instance. In fact, yesterday I was really excited because I went and wrote a new provider for the Azure SDK, only to find that somebody else had done it 4 days before me. So I was a little disappointed in that, but nonetheless, I'm super excited that we're going to see that in the Azure SDK sometime in the future. So this is the same app as Christos. I haven't made any other changes outside of creating a quick and dirty provider to talk locally to MSI, and then changing his startup code. So I'm going to go run this. So we'll do a .NET run, and we'll get back into the browser, and that's going to do a build. We'll get back into the browser, and you'll notice here that this is saying it's getting a token from localhost 40342, right? That's a service that's running on my machine, which is part of the Azure ARC service. And that's how it's actually getting these access tokens to go and talk to Key Vault. So if I go to localhost 5001, here's our app, and somebody's changing secrets behind my back. So this secret was gone. We went and pulled this secret at runtime. The secret went and got pulled. from Key Vault using an access token that was created by Azure ARC. And part of what makes this so interesting is I'm not using any of my credentials. In fact, my user account does not have access to Christos's Key Vault at all, outside of being able to look at it. So if we go look at an access policy and you go look at these secrets, you'll notice my personal user account, me as a user, I'm not in this list anywhere. So the only thing that's in this list that I have access to is my machine. So my machine has access to the Key Vault, and so my machine can run as itself and talk to Key Vault, right? So this is something I personally am super, super excited about, because now I get the benefit of managed identity as a true sort of proper managed identity running on my machine, instead of being in a position where I'm running code locally and it's running as me, but when I move it to Azure, it's running as a different account. And so my access and the principal's access are very different from each other. Now I can do exactly what I need to do and test MSI locally and keep those permission sets in check.
Awesome. Right. So hopefully at the end of this session, you're walking out with some great information about how can you create secretless apps running locally on your local machine with the right privileges and the right accounts, and keep it consistent.
Yep.
There you have it. And if you like what you saw, then make sure to jump on the 45 show. Make sure to join us every Monday and Friday at 8 a.m. Pacific or 5 p.m. Central European time, and ask questions, come build stuff with us. We'd love to have you. Thank you very much, everyone. We hope you enjoy the rest of the Build conference. It was great to be here. And thanks for JP for getting up at the crazy o'clock to join me as well. Thank you, everyone.
Thanks for having us.
Thank you, John and Christos. Just a quick reminder, if you have any questions, you can join a chat with a speaker, which you can find under Nirvana stage. And John and Christos will be there for you to answer to your questions.